the analysis and applications unit. In this unit, we'll try to make sure that we understand the difference between stacks and queues, and we're going to look at some applications of both these data structures. First, now that we've studied stacks and queues, let's make sure we understand the difference. When we discuss stacks, we established that stacks is a last in, first out data structure, which means what goes in last comes out first. In case of queues is a first in, first out or FIFO data structure. So what goes in first comes out first, what goes in last comes out last. Once you totally understand this difference between the two data structures, we should go and try to understand some of the real life applications that these data structures might have. So for queues, let's think about a computer. So a computer has to perform many processes. Let's assume the computer that I'm using needs to perform processes P1, P2, P3, P4 and P5. And the computer wants to perform these in this particular order. Now I'm doing a lot of stuff on my computer, so I keep on giving commands to my computer to perform certain processes. Suppose I gave the command to do process P1. Now P1 takes a lot of time to execute itself. Meanwhile, I'm giving commands to the computer to do P2, P3 and P4. So the computer will store these processes in a queue so that it knows that when P1 finishes its execution, it has to execute P2 next. So it will dequeue from this particular process's queue and it will then execute process P2. Meanwhile, if I have already given a command for process P6 and P7 to be executed, these processes will get enqueued to this process's queue. When P2 is done being executed, this will be dequeued and the next process, which is P3, will start executing itself. Let's look at how we can solve some problems using a stack. So suppose my problem is that I want to tell whether a particular sequence of brackets is valid or not. Now I know that if I have an opening bracket and a closing bracket, this is valid because every opening bracket has its closing bracket. A sequence such as opening, opening, closing, closing is also valid. If I append another two brackets to this, this still remains valid. But what if I add two more closing brackets to this? This sequence now does not remain valid because these two brackets are closing but they don't have an opening bracket corresponding to them. So how do we check the validity of such sequences? For this case, if you notice, what we actually need to see is the corresponding opening and closing brackets to each other. These brackets, so this bracket, the two that I've pointed out with green and the two that I've pointed out with black are corresponding to each other, but they're not always occurring adjacently. So what I can do is I can use something like a stack. So to evaluate this particular string, if I have a stack, I can have my algorithm as such that whenever I encounter an opening bracket, I'll put it into the stack or I'll push it into the stack. But when I encounter a closing bracket, I will pop one bracket from the stack because that one will be the corresponding bracket for the closing one. It's fine if you don't understand it. Let's look at an example. Suppose I encounter this bracket, which is bracket number 1. This is an opening bracket. So I can simply push it into the stack. Now I come across this second bracket, which is also an opening bracket. So I push this also into the stack. The third bracket that I encounter is a closing bracket. And if you observe, this closing bracket is corresponding to the second opening bracket that we've already popped. So when I encounter this first closing bracket, I'm going to pop from the stack. And the element that I end up popping will be the second element, which was actually the corresponding opening bracket to that particular closing bracket. Now when I come to the fourth element, this is also a closing bracket, so I need to pop again. When I pop this element, I will be left with an empty stack because this string, this substring in itself is valid, right? When I perform this same algorithm again and again, I will push for this opening bracket, then I will pop for this closing bracket. So this will be gone again. I will have an empty stack again. Now when I come to this bracket, it's a closing bracket. So I need to pop from my stack, but I don't have anything in my stack. That means that something is wrong or that this string is not valid. So in this way, we can use stacks and queues to solve different kinds of problems. What we need to observe is that whether the problem requires a first in, first out solution or a last in, first out solution.